The last part of this chapter, yay, it's the end, is about when we're doing what we were doing in the last one, where we're heating or cooling something to change its state. But it deals with heating and cooling curves. And I do these separately just because I want to take a little bit of time with it. Because it's a really interesting process. The heating curve, obviously, is we're going to be going up in temperature. So we're going to be going this way. All right. So we're going to be adding heat as we go, which is going to increase the temperature. And then what's happening is the substance is going to change as I add heat. Now, what's cool is there is a point up here, and we have already defined these, that there is a melting point of certain things. And if we were looking at like water, that would be 0 for water and 100 for water, right? That's the boiling point and the melting point. So if we're adding heat, it's a heating curve. So as we are adding heat, let me get my pen. As we are adding heat, all right, it's a solid. Okay, and so I'm adding, I'm making the temperature, I'm changing that temperature, I'm getting close to 0. When I hit 0, I'm at the melting point. And at that point, this substance is going to stay at that exact temperature no matter how much more heat I put. I could crank it up, put the Bunsen burner on, fire it up with a torch. It is not going to change the temperature until all of it is melted. Once I melt it, then it's going to, once it all melts and it's all a liquid, then it's going to rise in temperature, okay, until it hits the boiling point. At this point, then it's going to all be converted to a gas while it's boiling. But this temperature right here, it will not go up, no matter how much energy I put in there, until all of it is boiled away, and then that temperature will go up. All right, and once it hits that boiling point, then it's turning into a gas. So interesting is, once it hits the melting point, okay, it's melting, and so you're going to have solids and liquids because it's converting it from a solid to a liquid at its melting point. When it is climbing here, it's all liquid. When it gets to the boiling point, it's going to be a liquid and a gas. It's going to be a liquid until it all boils, and then once that's done, it's going to be a gas. So the heating curve is going up in temperature as you're adding heat, and it's going from a solid to a liquid to a gas. But it cannot change any of it from a solid until it hits that point right there. And then it's going to start melting. And when everything is done melting, then it'll be a liquid until it hits 100 degrees. And then everything, it will boil. And so it'll boil and be part liquid, part gas until it hits this last point. Everything's boiled off, and then that temperature can go on up. And then you can get like a superheated gas or whatever, or steam, which is hotter than 100 degrees C, which is why you can get burnt easier with steam than you can with water even. As you might imagine, a cooling curve is basically the opposite of what we just saw. In a cooling curve, we're going to go from a gas, okay, it's a vapor, okay, until I cool it down to 100 degrees. And then it's going to condense, and I'm going to have gas plus liquid until it's all gone. And then I can remove more heat, put it in the refrigerator, and then it's going to be all liquid until it hits the freezing point. and then I'm going to have liquid and solid until all of it is converted to solid, and then it can actually be lower than that and remain a solid. So your cooling curve is basically the opposite of the heating curve. Heating goes up and cooling curve goes down. And that's the only difference. And remember how we had those two coupled processes, boiling and melting, freezing and melting. Freezing point if you're going on the cooling curve, and melting point if you're going up to a liquid.